The next lecture here, basically, I wanted to look into some of the requirements that a laboratory will have to do to implement this into their system, which is basically the validation of the post-PCR cleanup. Because as much as I've said, it's a very easy process to do. When you put this into your lab, your interpretation procedures now may have to change, because all of a sudden now you're looking at stuff where before you may not have had anything, and now you're having a profile. And how are you going to interpret that? So the validation of the MinElute post-PCR cleanup. I'm going to cover the following topics: the type of required validation, the types of required testing for that validation, the number of samples needed for successful validation, factors affecting the validation, and satisfying audit requirements for the validation. The two types of validation defined in the quality assurance standards for DNA laboratory documents are a developmental validation, which is the acquisition of test data and determination of conditions and limitations of a new or novel DNA methodology for use on forensic and/or casework reference samples. Or an internal validation, which is the accumulation of test data within the laboratory to demonstrate that established methods and procedures performed as expected in the laboratory. So methodology is used to describe the analytical processes and procedures used to support a DNA typing technology. For example, extraction methods, quantitation methods, typing test kits, or platforms. That's what you mean by methodologies. So based on these definitions, the MinElute PCR purification kit for post-PCR cleanup is not considered a new method. It's a concentration and cleanup process. That's basically all it is. It's no different than the microcon and centricon. For MinElute, an internal validation will be required, so you will not have to do developmental validation on a MinElute. Depending on the requirements of the laboratory and before beginning the validation, some preliminary testing must be performed. If amplified product is retained for future testing, then either the volume of amplified product cleaned up or the volume placed on the genetic analyzer must be determined. So whereas in mine, when I was putting all of it and I was getting these great results, I did do somewhere I changed the volumes. And depending on your laboratory's protocols, some laboratories store the amplified DNA for a short period of time, some store for a long period of time. And then so your validation will have to take that into account, that you want product left over or you don't need to have product left over. The fold increase expected from the process depends on which of these volumes are chosen. If implementing the manual MinElute procedure, the number of washes to be used must be determined by the laboratory. The number of washes also affects the fold increase, as we saw earlier in the other presentation. Determination of volumes and number of washes to be used in the manual protocol will correlate to an expected fold increase. And this fold increase will vary somewhat based on pipetting differences between analysts. So obviously, you're going to probably have to set, if I do add this amount of cleaned up product to my genetic analyzer, doing this number of washes in your validation procedure, you would expect to see of this fold increase. But that will obviously change very slightly depending on pipetting methods and so forth. If implementing the QIAcube robot procedure, the number of washes will be 1 unless a change is made by the manufacturer. So you won't be varying the number of washes if you're going to use the QIAcube robot. However, changing volumes will still affect the fold increase. Due to more precise and consistent pipetting by the robot, there should not be much variation once an expected fold increase is determined. So I found that with the robot, because it's robotically done and you don't have much pipetting variation, you tend to get a good stable fold increase every time with the robot. Determination of the expected fold increase during validation will help the laboratory define the limits of the use of the MinElute system and when it should and should not be used. Okay, according to the new QAS DNA document effective July 1st, 2009, the following types of testing must be conducted as part of an internal validation: known and non-probative evidence samples or mock evidence samples, reproducibility and precision, sensitivity and stochastic studies, mixture studies, and contamination assessment. Okay, so let's start with sensitivity and stochastic studies. And the reason why I put that first is because you have to determine the limit of your system. And before you start looking to see about your contamination and how well it works on probative samples and reference samples and so forth, you want to know what kind of fold increase you're going to be looking at. Okay, so this study is important to see the quantitation threshold at which the laboratory will use MinElute. The threshold will vary from one laboratory to the next depending on their comfort level and how low they want to go to interpret data. The results previously presented showed an instance where there was no data before cleanup, but after cleanup there were peaks brought up to calling levels of 75 RFUs. In the last presentation when I showed you the peaks that were clearly in the baseline, but yet afterwards you were now able to see clearly and defined peak heights. So some laboratories may choose to only use this cleanup system on low-level peaks that are rarely visible but below the threshold. The only question with setting a limit of quantitation is whether your quantitation system is accurate. At the NFSCC, what was thought to be a problem with the sensitivity of the 3130XL was found to be a problem with the quantitation standards. When analyzing casework, there's usually a large peak height range that is accepted even though every amplification usually targets the same concentration. I think we've all seen this where we're targeting 1 nanogram, but do we always get everything at the same RFUs, even though I've targeted 1 nanogram? And that, what we found at NFSCC, where we were trying to actually get 1 nanogram, we thought at first our 3130 was having a problem. Because 1 week, 1 nanogram was, 1,000, 2,000 RFUs. 1 week, a nanogram was more like 1,000 RFUs. And 1 week, a nanogram was 3,000 RFUs. And we were like, what's going on with the instrument? Why are we having such fluctuations? I mean, we'd call AB in. They said, no, everything's to specs. There's nothing they can do. I think AB gave us a range of something like 300 to 3,000 RFUs for 1 nanogram, which to me is, that's kind of ridiculous. If you've got 1 nanogram, it should give you a good level all the time. So when conducting a kit study NFSCC in which the sensitivity of the amplification kits were being compared to each other, a lot of fluctuation was seen in peak heights from one to the next. This made study difficult and led the staff to believe the 3130 was having sensitivity problems. The 3130XL was not losing sensitivity. The peak heights were simply varying for all samples that quanted at 1 nanogram. After the instrument was checked and reported as being in working order, other processes were looked at. Apart from pipetting variations, the only other factor that could affect the accuracy was the quantitation results. The data showed that the standards supplied with the quantitation kit were giving a very different result when compared to standards from the National Institute of Standards and Technology. So, the NIST quant standards that are available out there. And the next two slides basically will show the differences in quant values based on which of these two standards was used to construct the quantitation standard curve. Standard A from the Applied Biosystems Quantifier Kit and the NIST Human DNA Quantitation Standard. Okay, so these quantitation values are using the Applied Biosystems Kit. The 1 to 50 dilution should be 1 nanogram, and the 1 to 10 dilution should be 5 nanograms. And you can see my 1 to 15 is about 2, 1.82, and then my 1 to 10 was 9. So that's like doubled of what they should have been. So basically, if you think you're targeting 1 nanogram, and so you think you have 9 nanograms of DNA, you're going to do like, what, a 1 to 10 dilution approximately to get your 1 nanogram. But what you really have is 4.5 nanograms. That's what you really have. So when you've done your 1 to 10 dilution to get 1 nanogram, you've actually diluted yourself down to 0.5 of a nanogram. And that's what you're actually running on your instrument. So what we thought was 1 week we were getting our 1 nanogram was high, and then 1 week our 1 nanogram was low. Where we thought the instrument was giving trouble, it was because 1 week our quant results, depending on the lot numbers of the quant kits, it was just varying so much from one kit to the next, even within the same kit. After we've used the same standard for a long period of time, not within its expiration time, we were seeing basically these fluctuations in the quantitation. So the correct values were obtained for the 1 to 50 and 1 to 10 dilution. Now, what we did here, we quanted the samples actually using the NIST standards to make our standard curve, which we know is not exactly fiscally feasible. I think it's about $1 nanogram, $1 microliter is what it works out to be, because it's like 3 tubes at 110 microliters, and it's $330 something for those 3 tubes. So it's about $1 a microliter for your NIST quantitation standards. So obviously, using that as your quantitation curve, I think it's going to raise the cost of DNA testing quite high real quick. But what you could do is what a lot of labs are doing now is on all their runs, they have a NIST standard. They place a NIST standard on there as a check of their quantitation. and you know what the NIST standard is, whether it's 5 nanograms, whether it's 1 nanogram, whatever you dilute it down to be, and then when you do your quant, you do a correction factor based on the fact that, you know, this NIST standard, which you know is like 1 nanogram or 5 nanograms per microliter, is now quanting at 10, or is now quanting at 2.5. So you can do a correction of all your data now from your actual casework to get the correct quantity that you're seeing. By using the quantifier standard to generate the quantitation curve, the quant results obtained for these samples will almost double what they actually are. Based on this, when you think you're amplifying a target of 1 nanogram, you may actually be amplifying 0.5 nanograms. And then this overestimation by double is not consistent. So it's not to say like, okay, every time I do this, I'm going to get double, divide by 2, I'm good. You know, it's actually wasn't. Double was, I think, the most extreme we've seen, but it was just basically varying levels anywhere from being correct to going as far as being doubled. When the quantifier standard is used to construct the standard curve, its quantitation accuracy varies from lot number to lot number, and sometimes the result was doubled, sometimes it was less. This inconsistency will make it difficult for laboratories to set a limit of quantitation. And if you're going to be implementing the MinElute system, and if you're going to, now this is depending once again how you want to use it. Some labs may say, well, here's what, every time I've got a concentration of this amount, 0.6, 0.1, I'm going to automatically MinElute, because I know that my peak heights are going to be this low, and I know that I'm going to need to MinElute to get it up to level. What we're suggesting is you do this quantitation study first, because it's going to be hard for you to set that limit if your quantitation results keep changing and keep fluctuating, because then you won't actually know what you're setting. Your procedures will say, you know, every time I get a quantitation of 0.1, I'm going to MinElute, but then 0.1 may not always be 0.1. Using the NIST human DNA quantitation standards to make the standard curve is not cost effective because of the price of the standard. When the quantifier standard is used to generate the quantitation standard curve, dilutions of a NIST SRM components can be run on each plate to help normalize the quantitation values for samples. Alternatively, the NIST SRM can be used to obtain an accurate value for each lot number of quantifier. Standard ASO designated quant values for each standard curve dilution point will be accurate. Okay, so back now to our study. So now that you've set your limit of quantitation, your actual quantitation level, and you have your quantitation correct, now you can go into your sensitivity study. Based on the MinElute validation study results, the limit of detection of the laboratory's quantitation system will also have to be reevaluated. Alleles will now be detected and can be easily distinguished from the baseline at much lower amplification concentration when samples are subject to MinElute. MinElute will increase the limit of detection. Alleles previously not distinguishable from the baseline will now be easily recognizable. Stochastic threshold will also change with implementation of MinElute. The stochastic effects caused by low-level amplification will become more visible with MinElute as the low-level peaks are brought to callable peak heights. Based on their validation results, it will be up to each laboratory to decide what data they are willing to interpret and report out what they will consider inconclusive. Whether a laboratory wants to interpret data that exhibits stochastic effects is up to the laboratory and their comfort level. So that's, you know, depending on your laboratory, what you want to do. Some laboratories may only work with data that's perfectly clean. Some laboratories may be willing to interpret data that has peak height ratio imbalances. With new rulings on what is considered a low copy number sample, it will be important for a laboratory's interpretation protocol to take into account the increase in stochastic effects that will now be visible when using MinElute. So it's not that you're getting an increased effect with MinElute, it's just that you're going to see it more clearly now. So, for example, you may have had something that's hidden in your baseline or just above your baseline. When you do the MinElute cleanup, you have its dropout. You had one peak showing up and then your other peak isn't going to be there. That's dropout. Before you could even tell it was present because it was mixed into your baseline, now you can clearly see that you have some data there, and this data is more visible now, but you have to remember it's low-level data. So it will have the same effects that you would expect to see, the negative effects with low-level amplifications. And obviously, any protocol that you put into place will have to be backed up by your validation studies. After the sensitivity and stochastic studies have been completed, the other required validation studies can be performed. The interpretation guidelines that were set based on the sensitivity and stochastic studies will be followed for the remainder of the validation. Reproducibility and precision studies. By analyzing samples in triplicate, reproducibility and precision can be checked. The mixture study will show the limitations of the MinElute cleanup process. MinElute will not work well for samples that have a high major contributor and low minor contributor. The MinElute PCR purification kits for DNA cleanup will still be useful in mixtures when the entire mixture is at a low level. Now, even though I say it will not work for a high major or low minor, I mean, remember what I did was I had maxed it out. Obviously, if you reduce your number of washes, or if you reduce the volume that you're placing on the instrument, it's going to affect the fold increase. So yes, when I got like a 10-fold increase, my major skyrocketed into the land of off-scale, and my minor, though pulled up, was getting interfered by the off-scale data. But if you have like a 5-fold increase, and you have a major 200 RFUs and a minor at somewhere maybe 30 RFUs, now your major isn't going to go off scale. Your major will probably only go to like 1,000 RFUs, and your minor will go up to about 150 RFUs. So therefore, that won't be as affected. But it depends, once again, so all these studies are going to go back to the number of washes you want to do and how much volume you want to place on the instrument. That's where you got to start. And once you establish that, then you can establish everything else. When the laboratory chooses to use MinElute on mixtures with major and minor contributors, testing must be conducted during validation to determine the maximum RFU level the major can be at prior to cleanup. By determining the maximum RFU level for the major contribute prior to cleanup, the laboratory will ensure the fold increase in the resulting MinElute data does not cause an increase in artifacts that interfere with interpretation of the minor contributor. The Contamination Assessment Study. Because MinElute does involve working with amplified product, the contamination assessment is very important whether the lab elects to conduct the procedure manually or with the QIAcube. Introduction of contamination can occur more readily when working with amplified product. Throughout the study, blanks should be incorporated. These MinElute blanks must be treated the same and interpreted as stringently as the analyzed samples. One thing I'll say about the manual process, I've had, when we've done training, I've had a lot of trainees, students, people who are DNA analysts, in training to become DNA analysts, do this process for the first time, and we've never seen any contamination. When you all do it, you'll see it's a very easy process. Once you bind your DNA to that membrane, there really isn't any way to get the DNA off of it unless you're going to put liquid in it and pour it on top of your hand or something to get the DNA to come off the membrane into your hand. Once you bind your DNA down there, everything is just spinning through a column. There's no inversion of the column. There's nothing like that you have to go through the microcon process. So actually, even though contamination is something that we're all worried about, and amplified DNA, you think about, oh yes, amplified DNA, we're going to have tons of contamination issues when you're dealing with it. The process, because it's so enclosed, even manually, I've never even seen any issues of contamination doing it. It's really not easy to contaminate unless you do something, like I said, like totally out of protocol, where you're putting solution into the membrane and then pouring the solution all over the place. I mean, that's really the only way you're going to get the DNA to come off of there. Because every time you spin down, you're spinning into a tube. And in your last step, you spin it into a clean tube and you cap your clean tube. The DNA never gets on the outside of the clean tube. It's trapped onto that membrane until you release it. On the QIAcube, when using the QIAcube, in at least one run, the instrument should be set up with samples alternating with blanks to demonstrate that no contamination is occurring within each run. That's basically, I did do that where I did every alternating on the QIAcube on the centrifuge. When I set up my samples, I did a blank alternating between my samples, and to make sure there was no contamination occurring from one sample to the next in the actual QIAcube. And then I did this where I did actually a run of all blanks after I did a run of all samples, just to make sure that nothing was being contaminated within the QIAcube, like the pipette tips, the reagents, anything like that. And there was none. There was no contamination from one run to the next or within a run. And the QIAcube, once you start it, you have to have the door closed to start it, and you can't really open the door again until, well, I'm not sure if it locks. Oh, it does lock. Okay, so the door locks, so you can't really open it up during the process. So the fact of the matter is, once the process starts, there is really no way to contaminate it for you to do anything from the outside. MinElute manual procedure contamination can be assessed by running blanks after every sample to demonstrate that no contamination is occurring within each run. So if you want to, when you're doing the manual process, if you want to run a blank after each one during your study to show that, that's up to you. There really, once again, wouldn't be any way to really cause the contamination unless something got on your glove when you were pipetting. But the actual spinning down process is always into a tube, and so the sample is always contained. Known and non-probative evidence samples or mock evidence sample study. After all of the other studies have been completed, the known and non-probative or mock samples can be run through the MinElute cleanup process. Most labs tend to overdo their validation studies. As long as the MinElute validation covers all aspects of how the kit will be used by the laboratory, the validation should be sufficient. The validation should be adequately detailed to allow the lab to answer questions that arise in the future by referencing the validation. No fixed number of samples are required, but for an internal validations, as few as 10 samples per study may suffice. So that's 10 per sensitivity, per reproduction, and so forth, not just 10 for the entire thing. One of the major factors affecting validation of the MinElute cleanup system is the comfort level with respect to the lowest RFU value the laboratory is willing to use when interpreting data. By the end of the sensitivity study, the laboratory will know what peak heights correspond to what quantity of DNA when using MinElute. The lab will take this into consideration when writing their interpretation guidelines for samples processed with MinElute. And this data would previously have been below threshold and therefore not suitable for conclusions. How to handle data that previously would not have been looked at will also affect the MinElute validation. For example, what if a low-level sample that previously would have been inconclusive, but now because of the MinElute cleanup is pulled above the calling threshold, and this shows that the suspect's profile is present or is not present. The fact is, when it was so low before, you may have said inconclusive. But now if you use MinElute, it's going to get pulled up, it's going to get called. So that's why you'll have to reset your interpretation guidelines when you implement this into your lab, because you will have data that in the past you would have been like, nope, can't use it, it's of no use to me, that now all of a sudden can actually be a lead in a case, can be matched to somebody. So this is actually going to be a big thing. We'll be changing your interpretation guidelines. Does the laboratory still report this out as inconclusive, or do you now make an actual report as an inclusion? The lab needs to ensure the MinElute validation is sufficient to determine how they will interpret and report data defined by various scenarios. The lab will need a sufficient amount of data to demonstrate that allelic drop-in is not occurring as a result of or during the MinElute process. When defining the parameters of their MinElute validation, each laboratory may also want to consider the impact of potentially lowering their calling threshold based on the results of the study. In some jurisdictions, this change may necessitate additional Frye or Daubert admissibility hearings. Because you can go from nothing to something, you as a laboratory, you're going to have to make that determination. Are you going to do that? You can have something that's hidden in your baseline, and then after you MinElute it, like I showed you, it's now callable, or it's clearly visible. And so you're going to have your validation studies to show that you don't have random drop-in is occurring, and that if you do get something called, it's actually DNA. And that's why the admissibility hearings may come into effect, because now it may look to obviously a defense attorney and so forth that you're producing DNA out of what previously was nothing. You put it through this process and you magically produce this DNA that of course happens to match the client or the suspect in the case. So it's something that you definitely have to take into account, is that you will now get results that you previously would not have seen before. Admissibility hearing requirements may assist in determining the number of samples per study the laboratory wants to run. The validation results must be sufficient to support a decision to adjust the lab's calling threshold for MinElute processed samples. Following cleanup, peaks will be visible that were previously at 10 RFUs or lower due to the fold increase seen with MinElute. While a traditional protocol RFU threshold of 100 set based on LOD, LOQ, and stochastic effects may be appropriate for that data, the lab may find that review of MinElute validation data supports setting a lower threshold. Sufficient data must be generated during the MinElute validation to support such a decision. Okay, for the audit requirements, after the MinElute validation is completed, the laboratory must write up a summary. The technical leader must approve the validation summary. The laboratory staff will then undergo training in the use of the adopted MinElute protocol. Before using MinElute and casework, each analyst must successfully complete a competency test. With proper documentation authorization, staff performing the validation may use their validation work in lieu of a competency test. MinElute training and competency testing can be completed in a day or two, regardless of whether the analysis is conducted manually or with the QIAcube robot. And you'll see that today how quick it is and easy it is to do the actual process. So the actual training and how to do the MinElute, whether it's with the robot or whether it's manually, is actually 30 minutes to train somebody. Honestly, there's nothing new you're doing with MinElute. There is no new, it's pipetting. It's taking a sample, putting it on a membrane, and using a centrifuge. That's really all it is. So when you have to train somebody in this and have them do a competency, it's something they've always done. They know how to pipette, they know how to operate a centrifuge. And basically, if you know how to pipette and operate a centrifuge and can hold a tube, you can do the MinElute procedure. So basically, it's something that training is will be extremely quick on, and a competency will be very easy to do. And the ability to rapidly complete analysis training and competency testing is due to the simplicity of the MinElute system. And like I said, all techniques are consistent with current techniques used by analysts. And that one was shorter. Okay, any questions on anything? Yes?
If the QIAcube decides to stop working or something occurs during the process, is that then indicated robotically that the analyst can clearly know what step it stopped at, so then the analyst could pick it up manually?
I believe the QIAcube, yes, it will give you a warning.
There's a log file. Every run is set to a USB stick that's on the system, and there's a log file, and the error code indicates where the issue occurred, and so you could take it out and finish it manually, for instance.
Did you have to do that at all?
No.
Did you look into that?
No, I didn't have any problems with the QIAcube. No. It's once you started it, and as it's going through the process, it's telling you in the little menu display everything it's doing. It'll tell you it's binding. Then when it starts the washing, it'll tell you washing step. It'll tell you elution step. It tells you like, so you know. So I mean, if you were just looking at it, not that you'd really want to sit there for 30 minutes and look at it, but if you were, like I did, you would see exactly which step you were at. I mean, you'd actually be able to see all the steps. So, you know, it was like I said, it was a pretty easy system, and I didn't have any problems with it. And like I said, you all get to use it today, so you'll all see how easy it is. Any other questions? I think the biggest thing with the validation is going to be interpretation guidelines. That's going to change for a lot of labs.
Do you have any recommendations for people to do mixture analysis based on what you saw in your studies to put that into their validation?
Well, like I was saying before, first of all, you have to determine what volumes and how many washes you're going to do, or if you're going to use the QIAcube wash. So first of all, you have to determine what your fold increase, what your expected fold increase is going to be for your samples. If your fold increase, if you're going all out and you're going to go like a 20-fold increase or something like that, if that's what you end up setting because you're doing the most number of washes you can do, you're putting all of that sample onto your genetic analyzer, then it's just a simple, the mixture is basically it's going to come down to what level can you have a major at that you can get that fold increase and not blow it out. Because, I mean, we can all increase something from 200 to 1,000 or even to 2,000 RFUs and still not expect to get pull-up or any of the other byproducts of off-scale data. So we can, if you keep it at a level like that, you'd be fine within a mixture. It's only if your mixture, like I said, I had something like a 1 to 20 and 1 to 15, which is, you know, like really high, where the major was so high to begin with that any increase made that off-scale. So it would have, I would think for a validation study, what you would need to do for your mixtures is basically set the upper level that your major can be at based on how much your fold increase you expect to get. So if you work it out and it's 5-time fold increase, then you go through, when you're doing your mixture study, you'll see how high can I have my major initially starting at, that when I do that 5-fold increase, the data is not causing me problems with interpreting my minor. But so it's not that it can't be used in mixtures, it's just going to be determined on what the laboratory is going to, what kind of fold increase they're going to want to use it at. Yeah.
Have you seen the application of this being put into case working laboratories with what it's doing to the limit of detection and stochastic thresholds? Like how much of a jump are laboratories seeing for stochastic thresholds?
I know there's some laboratories that are looking into it. I want to say I don't know why I'm thinking California, because when I did a post at Promega last year, they seemed to be they were very much like they were already validating it, but I don't know what they've set as a stochastic threshold. Perhaps that's something that maybe we could. I don't know if QIAGEN has any information of any labs that are using it in casework. Maybe what could be a good thing is to have an idea of what they may be setting their stochastic thresholds at, just to help other laboratory systems that want to implement it to see what other labs have done in the beforehand.
I think to reduce the amount of variables, I think people are keeping their RFUs where they're at. Kind of the example Robert talked about before is saying, okay, well, my threshold in my laboratory is set is 150, 125, whatever it is currently. But then to that same question, analytically you look at it, as a scientist I should say, you look at it and say, there's a profile there. So they chose to go with it, and then they just kept the same levels. Now, when you start getting into some of these complex, that's easier said than done with single source versus mixtures. And so that was, so a lot of them kept their thresholds where they were, and then they just did the data analysis from there. Again, New York State is probably most progressive there. They're starting to go into secondary interpretation rules, and they've been spending probably the last 2 months doing that. But they've put it online, they've used it for casework, and Jay Caponera, who's kind of heading that up, he's also used it at a previous life when he was doing some forensics with wildlife services. So he had actually had some experience with it there. Arizona, I don't think, I'm not quite sure what they do currently. I know that, again, they started keeping thresholds the same. But it definitely, when you get into the mixture analysis, that's that next level that they're looking at. But when you had like a blood stain and somebody, you can see it's a single donor, then that's where they again just held as many interpretation rules steady as possible. But I'd be happy to pass on Jay's information, or maybe what we could do is just put some users, some of the MinElute users, in a sheet that if people wanted to contact them and say, what is your practical experience with it, I think that we could easily do that. We have a lot of customers, probably about a dozen or more, that are in validation right now, so we don't have enough data points. We don't have enough data points to say, where is it at in routine casework. Because I think, as you know, this industry is a following industry. Everyone, now that it's been published a couple times now, people are starting to say, okay, I'll try it too, and we're in that phase of, I'm still validating it too. But I think there's we can probably expect to have another webinar coming up, probably in the last quarter of the year, if not early next year. But I do know, if you're going to Promega, I know that North Louisiana is going to do a little bit more extensive information on their work with the bone sample. So they're going to be publishing there. And I know I think 2 other papers or posters that were accepted. So more than likely you'll also start seeing some more there, much like Robert. I think last year, I want to say there was maybe 3 posters, and I already know 3 or 4 again this year. So we're seeing that kind of normal progression within the forensic community, bringing it online.
Right.
Yeah, we have ours validated, the summary's written, and now we're at the point of trying to figure out exactly how we want to implement it and but we did the same thing. We're sticking with our original RFU threshold right now, and basically looked at a picogram amount where we were going to see stochastic effects, so we're not going to amplify anything below that one. And now we're just trying to figure out if we're going to use it routinely all the time, or we're going to go ahead and shoot those samples normal and then go back and clean them up if we see something that's below the threshold. And as for the mixtures, I think right now we've just decided to try to use the data for exclusionary purposes and not really worry about trying to include somebody with those lower level ones. Like most labs were getting a lot of that kind of stuff, and right now we don't do anything with it. We just say we can't make any kind of conclusion, so we're hoping to make at least the leap to be able to exclude somebody from a particular sample where before we weren't able to say anything. So that's where we are now, is trying to figure out what we want to do and start writing our policies and get them in place.
One of the things I think is and you alluded to it, is kind of, paraphrasing our old president, but what is, when you're quanting, if your procedure is based on what your quant level is your quant your quant? That's been probably the biggest question until we probably see these NIST standards come down in a mountain. They're more feasible, like you said, fiscally. The question is, do you make a choice to do something or not based on quant data or STR performance? And those have, we've seen, as a kit manufacturer, there's quality. We do every bit of quality control we can. QIAGEN, I think we have good ones, quality measures, but there always can be something. I mean, there wouldn't be a need for MinElute cleanup if there wasn't some sort of issue with the type of chemistries and stuff we use. So it's the question of where do you make your choice of that it might need cleanup. That's probably also the other part you have to consider.